Somewhere along the last 10 years, DevOps stopped being a philosophy of how to develop software and started to be a sales tactic. That shift, I think, has caused many developers and operations engineers to lose trust a little bit that DevOps can actually make their jobs better. Developing software is hard, it just is. We solve complex problems, often with complex solutions, every single day. That complexity is what makes communicating with your colleagues such a challenge. Code isn't the hard part of software development. Instead, it's compiling, literally, the work of everyone on your team into a cohesive, polished product that brings real value to your customers. I think everyone in this session has stood through an hour-long stand-up in a room with a tall table and no chairs, argued for 15 minutes on whether a feature was an 8 or a 13. Heck, you might have even done it this morning. The truth is, any production database older than 2 weeks is basically held together by duct tape and positive thinking. It's true. There are plenty of anti-patterns in our work, and you've probably experienced most of them. I'm Emily Freeman. I'm the author of DevOps for Dummies and a principal cloud advocate at Microsoft. I am obsessed with helping technology organizations transform themselves by creating company cultures in which diverse, collaborative teams can thrive. Knight Capital is by far my favorite DevOps story because you couldn't write a better story to show why culture, not tooling, is the foundation of DevOps. In 2012, Knight Capital received notice that the New York Stock Exchange was opening its dark pool called the Retail Liquidity Program, or RLP, after getting the go-ahead from the SEC. In simple terms, a dark pool is a sort of private market that operates outside of public scrutiny. Knight Capital needed to integrate with the new dark pool because they were what's referred to as a market maker. They made money on the delta between buy and sell prices on stocks. If trades took place in the dark pool and Knight Capital wasn't involved, they would lose money and risk their foothold in the market. That's not good. Now, at the time, Knight managed an average daily US equity volume of more than 3.3 billion trades, worth roughly $21 billion. That's insane. Knight had just over 30 days between the RLP approval and its go-live date of August 1st, 2012. With an incredibly short deadline, the engineering team got to work. You can imagine the stress that development team experienced. I get a little sweaty just thinking about it. Whew, that's fast. But here's the kicker. To integrate their system with the RLP, Knight Capital would have to make changes to the trade execution system, including the high-frequency order router, referred to as SMARS, short for Smart Market Access Routing System. Naming is hard. SMARS could execute thousands of orders per second and was designed to compare prices across all markets within a fraction of a second. Now, as you might imagine, SMARS was a relatively complex algorithm, and SMARS was old, at least in terms of software. It contained unused legacy code, sometimes referred to as dead code. Part of this dead code contained an algorithm called PowerPeg, which was sunsetted in 2003, nearly a decade earlier. That's bad. PowerPeg was a test program that bought high and sold low. Now, if you're thinking that kind of breaks the basic fundamental rule of stock trading, you are correct. PowerPeg was never intended to be used in a production environment. Instead, it was used to sort of verify the behavior of other night trading systems, like a test for a staging environment. The engineering team coded feverishly for nearly a month, planning to deploy the new system using a feature flag a week before the deadline of August 1st. Now, on the go-live date, they would simply flip a switch on the feature flag, and Knight would be trading in the RLP. During that last week of July, an operations engineer manually deployed the new RLP code in SMARS to 8 servers. There was no peer review to ensure everything went well, nor was there an automated system to provide an alert if the production code or behavior was inconsistent. At 9:30 a.m. Eastern Standard Time on August 1st, engineers flipped the switch on the feature flag, and SMARS began to route orders through the RLP. But everyone could see immediately that something was off. Internal charts showed strange spikes in activity, and 4 minutes later, the New York Stock Exchange called. Knight Capital was executing so many orders that the entire market's trading volume had doubled. And perhaps more alarmingly, Knight appeared to be buying high and selling low. Knight was losing thousands of dollars per second. Per second! No outage is cheap, but that is a nightmare, folks. Everyone jumped in to try and find the bug, but no one could quite pinpoint the issue. Orders were originating from the new router code, but that's about all they could see. The code looked right. Tests passed. Everything looked like it should be working. After 20 minutes and no solution, the CIO made the decision to roll back the deployment. It wasn't ideal. There would be an explanation needed, but it would stop the bleed. Only the rollback failed. As soon as they released the last stable version, the SMARS software trades spiked again. When the developers shut down the entire system completely, 28 minutes after the market opened, Knight Capital had lost $460 million. That is over $16 million per minute. Knight Capital was finished. They were eventually acquired for pennies on the dollar of their original value. So what happened? Well, it turns out the issue was that when developers updated that legacy code, they repurposed the feature flag that had been used to disable that same code. Unfortunately, the ops engineer who deployed the new build to the servers, he made an error during the manual deployment. Only 7 machines were updated, leaving 1 running the old code. Because the feature flag was reused, traffic hitting that 1 machine called the PowerPeg program, that algorithm that bought high and sold low. The rollback didn't have the intended effect because no one thought to turn off the feature flag. In fact, the rollback intensified the problem because when they reverted to that last stable build, all 8 servers were running the legacy code instead of just that 1. Now, these engineers, they weren't stupid people. They weren't using bad tooling. This was one of the leading financial institutions of the time, and Knight hired some of the brightest people in the industry. As with any service outage or degradation, there were a number of contributing factors, which I'll discuss in a moment. Hiring great engineers is just one piece of the DevOps puzzle. Allowing those engineers to thrive and to be the absolute best performers they possibly can be, that requires thoughtful planning and work. DevOps is a philosophy, a methodology that prioritizes people over process and process over tooling. When I ask people what's going wrong in their DevOps practice, they almost never tell me that it's a tooling issue. And even when it is, It's usually about how their team is using that particular tool rather than a problem with the product itself. If you put tools first, all you accomplish is automating and obfuscating the bad habits that already exist in your organization. Knight Capital didn't fail because they chose the wrong CI/CD tool. They careened toward disaster because of a series of relatively small, poor decisions that compounded into a nightmare scenario. I bought a house last year, and the yard is a mess of weeds and vines and, well, mostly dandelions. I've been diligently picking them out of my yard in a slow, endless battle that I'm probably losing. This little tiny flower, it was so magical to me as a child, but has become quite the nuisance in my adulthood. But the dandelion, I think, embodies a lesson. Weeds can grow in the worst soil. Clay, rock, sand. Weeds find a way. But truly productive plants, the kind that provide us life, they require a more hardy, rich environment. Farmers must care for the soil on their land, balance the acidity, add nutrients till the dirt, rotate crops. It's hard work, but the effort bears fruit. DevOps is centered around a few core principles. You can think of these as the work you must do before you ever think of planting the seeds of tooling. It is in embodying and executing on these principles, when your actions reflect the ideas, that you begin to truly transform your organization. DevOps starts with leadership. And I want to be clear that you don't have to be a manager to be a leader. Empower your team, share responsibility, create cross-functional collaboration across engineering teams and disciplines. Your team should feel free to make independent decisions based on their expertise. Collaboration, it starts with trust. Your day-to-day interactions should be opportunities for people to freely share their challenges and pitch in to help. Meetings and activities should have a human component so that the people on your team can start to build rapport. The bottom line is that it's much easier to get through product and architecture disagreements if you trust the people with whom you work. Cross-functional teams in which members have complementary skill sets are ideal for establishing a culture where information is shared freely. And it eliminates this sort of not my job attitude. One of the best ways to build these is to hire people who don't just have the technical skill set you need, but also have this sort of natural curiosity. These engineers often embody a dogged determination to figure it out, and they will grow to support each other over time. Create opportunities for people to teach each other more about their disciplines. This is especially important for developers who need to learn about infrastructure and configuration management, as well as operations engineers who need to better understand the complexities and difficulty in writing reliable code. Failure is unavoidable. It just is. You cannot outthink or outsmart failure as much as we try. It just doesn't work. If you have one operations engineer for every 20 developers, you're going to have an issue. People burn out, especially when they're on call. So ops folks need to create open access to telemetry and logs so developers can actually learn. And developers, in turn, need to support the operations team by being added to the on-call rotation. Practicing failure is incredibly important. My favorite exercise is to take the most senior engineer on your team. You know, the one, they've been there forever, they know the system in and out. Yeah, take her laptop away. Send her on a long vacation, I guess staycation. And see how the rest of the team actually manages without her. You'll learn a lot about the human dependencies in your system as well as the technical ones. and both are important. Communication is something undervalued in tech. We focus so much on that sort of raw engineering intelligence that we overlook the ability of some to convey technical concepts to others clearly. But I think it's communication that separates the truly phenomenal, disruptive teams from those who simply maintain the status quo. Try to make time to communicate over video rather than just email or chat. It's a more efficient and nuanced form of communication that conveys more than just the words. Though be aware there is a fatigue, so don't over-inundate them with video calls. Provide your engineers training in those sort of soft skills. They're actually quite hard. But you want them to be able to convey those technical concepts to not only their peers, but also teams like sales and marketing. One of the challenges DevOps faces is its implementation. It is much easier to conceptualize the values I just discussed than it is to actually inject them into your work environment. The reason implementation is hard is because we all work at different companies, and each of those companies has different people and resources, constraints. I really wish I could hand you a checklist at the end of which you could declare DevOps victory and be done. Instead, there are a few things that we can learn from Knight Capital and implement them right now to strengthen your DevOps practice. Old, unused legacy code should always be removed. Delete, delete, delete. We have source control for a reason. You can always go back and find code if you actually need it. But I promise you, in 99% of the cases, you won't. In that same vein, please never measure developer efficacy by lines of code written. Sometimes the best thing an engineer can do is delete thousands of lines of code and dozens of files. Make new feature flags for each component or service or update. If you're unfamiliar, a feature flag is it's a wrapper of a specific feature or service or product. And a binary flip is stored in the database to tell the program whether to use that code in production or to keep it hidden. It is a great way to establish continuous deployment in your system by allowing engineers to constantly deploy their new software without actually releasing it to your users. Rushed deadlines are never a good idea. Sure, Knight Capital didn't know for sure that the New York Stock Exchange would receive approval to open the dark pool, but they knew it was in the works, and they could have been preparing for this ahead of time. Yes, if the SEC had blocked the dark pool, Knight would have wasted engineering hours. But I think sometimes it's worth the risk. Deployments and releases is where tooling like Azure DevOps really starts to shine. That poor lone engineer who deployed the new code manually across 8 machines made a mistake. We make dozens of mistakes a day. I certainly do. And constantly relying on humans to behave consistently is risky at best. Automate integrations and deployments through a CI/CD pipeline as much as possible. Every manual task involved in a software release is an opportunity for error. But make sure that those automated processes are supported by a robust test suite. It's clear that Knight Capital did not write tests to accompany each new feature and bug fix. That said, Knight engineers had received alerts from their system that something was wrong. Earlier in that morning of August 1st, the system generated 97 emails that identified an error described as power peg disabled. But the emails were obscure. They had no clear call to action and were mostly ignored. If your alerts are confusing, unclear, your team simply receives too many of them. They'll develop alert fatigue, and essentially people just stop paying attention, which is about the worst possible reaction. Finally, practice incident response. Knight Capital had no plan for how to handle a service outage. The CIO and his team were making decisions in real time based on the data that they had, and it wasn't good enough. You need a plan for how your team will handle incidents as they arise. No, you can't write a run book for every single thing that might come up. But the more resources you provide engineers, and the more practice they have in handling those sort of small scale incidents, the better prepared they'll be when a truly horrific situation strikes. DevOps isn't a silver bullet, but it is a framework in which you can design company culture so that everyone can thrive. I believe engineers who are proud of their work and proud of their workplace produce software that is better, faster, and more reliable. Thank you.